Have you ever looked at the intricate face of a classic pocket watch, seen those tiny, sparkling red jewels, and assumed they were mined from the earth? It's a natural assumption. But what if I told you that over 250 years ago, watchmakers had a secret? They weren't using natural gemstones. They were creating their own perfect, synthetic rubies in a fiery furnace, in a process lost to time for centuries. This is the story of how 18th century ingenuity solved a very tiny but critical problem: friction. In the quest for precision timekeeping, watchmakers faced a constant enemy. The tiny metal axles, or pivots, of the watch's gears would spin constantly against their metal bearings. This created friction, which led to wear, which led to inaccuracy, and ultimately, the failure of the watch. They needed a material harder than metal, with an incredibly smooth surface and resistant to wear. The answer was corundum, the mineral family that includes ruby and sapphire. Natural rubies were, of course, prohibitively expensive and difficult to shape with the required microscopic precision. They needed a better way. Enter a French naturalist and watchmaker named Pierre-Victor de Rizy. In the mid-17th century, he was experimenting with the chemical residue left behind after melting gold. But the true breakthrough came from another French chemist, Pierre-Joseph Macquer. Their discovery was a process now known as Verneuil flame fusion, though it wouldn't be named that until Auguste Verneuil perfected it over a century later. But the 18th century pioneers laid the groundwork. So how did they do it without modern technology? The secret ingredient was goldstone. No, not the glittery rock you find in gift shops today. This was a specific powdered byproduct from the goldsmithing process. When gold was purified and worked, it would leave behind a waste powder. This powder wasn't just gold dust, it was contaminated with traces of other minerals, and most importantly, it contained a significant amount of alumina, the base material of corundum. The watchmakers would take this goldstone powder and mix it with a small, precise amount of a chromium compound, often a mineral like croquat or a chromium salt. Why chromium? Because chromium is the element that, when introduced to alumina, gives ruby its iconic deep red color. This fine, red-tinted powder was their raw material. Now, for the fire, they used a specially designed high-temperature oil lamp. Think of a sophisticated, powerful Bunsen burner. They would blow this powdered mixture through a fine oxyhydrogen flame. The key was the incredible heat of this flame, over 2,000 degrees Celsius. As the fine particles of alumina and chromium passed through the heart of the flame, they would instantaneously melt into tiny molten droplets. These droplets would then rain down onto a ceramic pedestal placed a specific distance below the flame. Drop by drop, over hours, these molten particles would accumulate and crystallize. On that pedestal, they weren't just building up slag, they were growing a single, continuous crystal. A perfect, cylindrical boule of synthetic ruby, forming layer by atomic layer from the bottom up. Once the flame was extinguished and the boule cooled, they had their prize: a rod of pure, lab-created ruby. It was chemically and physically identical to its natural counterpart, but without any impurities or flaws. It was, in many ways, superior. This rough ruby rod was then handed to a specialist, the jewel piercer. Using a bow-driven lathe and a sharp tool tipped with diamond dust, the only substance hard enough to cut corundum, they would painstakingly slice the rod into tiny blanks. These blanks were then drilled with hair-thin holes and polished to a mirror finish, creating the perfect, hard, and incredibly low-friction bearings for the watch's movement. These jewels revolutionized watchmaking. They drastically reduced friction and wear, leading to timepieces that were more accurate, more reliable, and longer lasting. So, the next time you see one of those tiny red jewels in an antique timepiece, remember, you're not just looking at a gem, you're looking at a testament to the 18th century innovation, a masterpiece of synthetic chemistry, born from fire and human ingenuity, all in the relentless pursuit of a single perfect